Hello, I'm Sunggeun Kim, a PhD student of Texas A&M University. In this video, I'm going to talk about a memory stage of y8664 sequential processor implementation. Let's get started. Okay, this memory stage is relatively simpler than other stages, so it will be easy to implement. So in the figure of memory stage, we have data memory, and we have four control logic. So the first two is mem read and mem write. So these two control logic generates 1-bit signal each to read or write. So if the current instruction reads data from the memory, the mem read control module will generate read signal. And if the current instruction is writing data from the memory, writing to the memory, then the mem write control logic will generate write signal. But it should be it shouldn't have both read and write one. Okay, so then it will be error. Okay, and then next two conditional control signal. The first one, memory address, generate memory address to either read from or write to. And next control signal actually generates data to write to the memory. Okay. Yeah. And then for the memory, data memory, it is almost same configuration with instruction memory, but it could be something somewhat different that I didn't mention in this tutorial. But as long as you make the same address width, data bit width, with the same with instruction memory, then it should be fine. So in my case, I'm using 12 bits for address bit and 8 bits for data bits, and it is byte addressing, so 4K byte in total size, and it returns 1 byte per cycle. It is all the same with instruction memory, and it takes 8 cycles to read a quad word, which means it is 8 bytes. Okay, so we didn't talk about actual the size, the type of data in the memory, because we didn't have memory data memory before. But in y86 64-bit architecture, it is allowed to use only one type of data in the memory, which is quad word, and its size is actually 8 bytes or 64 bits long. Yeah, so since we have a same this setup with instruction memory, so we can use the same Logisim memory file to load data to this data memory. So this is instruction memory, but it should be a data memory. But I just take this image from the previous slides. So yeah, and then so again we have our new table that has all the selection logic of each input to the memory memory module. So based on this transformed computation table for memory stage, so we have all the computations with all the instructions. So let's take a look at the RM move instruction and MR move instruction for an example. And then we will select inputs to memory module from these 4 control signals that we introduced in the previous slides. So for RM move instruction, we move the value of register A to memory address D plus RB. Then in the memory stage, it writes the value A to the memory address val E. Then how many bytes we write? We write 8 bytes because size of register is 8 bytes. Okay, then for this instruction, so what kind of the signal we need to generate? So for the read signal, is it read signal? Is it read instruction? No, it is write instruction to the memory. So we put 0 here, and then since it is write instruction, so we put 1 here. And then for the memory address, so memory address comes from where? Val E, which is effective address computed by ALU. So we generate we select val E as inputs to the memory address. And then actual data, where the data we need to write is in the val A, which is from the value of RA, the register. So we select val A. Okay, and then for the MR move instruction, which read the value from the memory address D plus RB and then put it to the register RA. So over here. Then we again read memory address at val E, which is actually RB plus D, and then how many bytes we read from memory? 8 bytes, and then put this value to the memory value M. And since it is read operation, read instruction, we select 1, and since it's not write, so select 0, and the memory address is from val E, and then it is not data write, so we don't care actual input data. Okay, so then you can fill up this table for the other instructions yourself, and then implement those 4 control signals. Okay, that's it for memory stage. Even though I didn't mention the status module in the memory stage, we can just simply ignore that because it's not very useful, as I mentioned in the previous tutorials. And in the next video, I'm not going to demonstrate just PC stages because it's very simple, and so after I talk about PC update stage, then I will give you a full demonstration with the complete processor. Thank you.